Hi everyone. Today we will be discussing about plus 1 physics chapter 1 physical world. What is science and what is called scientific method? Science is a systematic attempt to understand a natural phenomena in as much as detail and depth as possible and use this knowledge so gained to predict, modify and control a phenomenon. The detailed so we are studying science as a systematic attempt to understand a natural phenomena. So there are many natural phenomena occurring in our surrounding. For example, a coconut falling from a coconut tree. So when a coconut gets fall from the coconut tree, we are seeing that, and we are we are studying that phenomena in a detailed and depth. And from this studying, we will get a knowledge, and this knowledge is gained to predict, and the knowledge we gain may modify and a control phenomenon. So this is what a science is called. Science is exploring, experimenting, and predicting from what we see around us. So, science is always an exploring, an experimenting, and prediction of what we see around our nature. Now, what is scientific method? The scientific method involves several interconnected steps: a systematic observation, controlled experiment, qualitative and quantitative reasoning, a mathematical modeling, prediction, and verification or falsification of theory. So, what is a scientific method consist of? It consists of a systematic observation. When a coconut is falling from a tree, we are seeing and we are observing that phenomena. When we are continuously observing the phenomena. So observation is very important. So first method is observation. So systematic observation. Then a controlled experiment. Similarly, we will be doing the similar experiment. Instead of a coconut falling, we will be putting a ball from our hand into the ground. So it's something similar to it. So we will be doing a control experiment. Then we will be having a qualitative and quantitative reasoning. So what is qualitative and quantitative reasoning? So this is how a natural phenomena is occurring. We will be observing. First, we will be making a mathematical formulas related to this. That is called as quantitative reasoning. And related to the falling of object, we will be making a mathematical concept. Using the mathematical concept, we will be solving the skills we observed. And what is qualitative reasoning? Qualitative reasoning for a physical system. We will be observing its structure, how it starts, how it ends, how it happens. This is what we call as qualitative and quantitative reasoning. Then a mathematical modeling. Mathematical modeling means we will be finding the mathematical equations. We will be connecting into the mathematical formulas we have. Then prediction and verification. We will be predicting. It may be because of a force. For example, if the coconut falling from the tree, it may be because of the force it's falling. So we will be predicting. It may be. So we will be proving why. Why is there any force acting in between? We will be doing whether what we have predicted is true or false. So prediction and verification or falsification of theories. These are the methods involved in scientific methods. Now, what is physics? The word physics comes from a Greek word meaning nature. So, physics comes from a Greek word meaning nature. In physics, what we do is we attempt to explain diverse physical phenomena in terms of a few concepts and laws. So, in physics, we are explaining the physical phenomena in terms of few concepts and laws. Physics basically divided into two based on the domain, that are macroscopic and microscopic. In a macroscopic domain, it includes the phenomena at laboratory, terrestrial, and astronomical case. So, what the phenomena is happening in our surroundings, that are macroscopic domain. Especially in our laboratory, we are using that phenomena in the laboratories. That is macroscopic. Then terrestrial. Terrestrial means with the surrounding of Earth. Earth, planets, what happened between the planets, what happened between the Earth and Moon, astronomical scale. Yes, beyond the universe or in the universe, what's happening. For example, the distance, how a star travels, how the light is produced from the star. These are macroscopic domain. So these phenomena will be included in the macroscopic. It means the large scale. Now, in microscopic domain, we will be using something very small, that may or may not be visible to our eyes. So, in microscopic domain, we use atomic, molecular, and nuclear phenomena. What is happening inside an atom? What's happening between the molecules? How inside a nucleus of an atom? That is what we studied in microscopic domain. Classical physics. It's a big classical physics is a big branch that includes in macroscopic phenomena. It includes the subjects like mechanics. Mechanics is the subject which deals with the motion of an object, the properties related to the motion. Next, electrodynamics. What is electrodynamics? Electrodynamics deals with the study of electricity, magnetism, etc. Then optics. Optics deals with the study of light, how the vision is produced, etc. So in optics, we will be studying about the light phenomena. And next is thermodynamics. Thermodynamics, it deals with the study of temperature of a dynamic substance. It means when the particles move, the temperature, how the temperature varies. What is the temperature? Thermo means temperature. So in classical physics is a branch of physics which deals inside macroscopic phenomena, which includes subjects such as mechanics, electrodynamics, optics, and thermodynamics. In microscopic domain of physics, it deals with the constitution structure of matter at minute scale, especially inside an atom, nuclei, cell, and even lower scales of length, and their interaction with the probes such as electrons, photons, and other elemental particles. So, their interaction or how the interaction between electrons, photons, protons are occurring. So, these are we study inside the microscopic domain, and this branch is called as this study inside the microscopic phenomena. The best example is how quantum theory, quantum mechanics, these are the branches inside the microscopic phenomena or microscopic domain. So quantum theory is mainly is the study between the electrons, photons inside an atom. Now the main topic of this chapter is fundamental forces in nature. There are mainly 4 fundamental forces in nature, that are gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. First one is gravitational force. Gravitational force is the force of mutual attraction between any two objects by the virtue of their masses. So what is gravitational force? It is a force that acts as an attraction. It is an attractive force. So there are mainly two types of forces, that is either attraction or repulsion. So, gravitational force is an example of attractive force which acts between two objects by the virtue of their masses. It is a universal force. So gravitational force is always a universal force. All objects on the earth, for example, experience a force of gravity due to the earth. So every object in the world or in the universe experience the force, that is gravitational force. So between the sun and earth there is a force, there is a gravitational force. Between the earth and moon there is force, and similarly between the many stars, everything be inside a universe, there is a force, and that force is called as gravitational force. So it is a universal force. So sun, between sun and moon, sun and stars, between earth and stars, between the galaxies, everywhere the gravitational force is being experienced. It is up to range 10 raised to minus 31. The motion of the moon. How a moon is moving around the earth. The artificial satellites move around the earth. How it's moving. The motion of earth and the planets around the sun. The sun itself is moving. A galaxy itself is moving. Everything, the gravitational force is being controlled in between. Next one is electromagnetic force. Electromagnetic force is the force between charged particles. So we have studied the force gravitational. It is an attractive force. So electromagnetic force is a force between charged particles. It can be attractive or repulsive. So according to the Coulomb's law, attractive forces are for unlike charges, for a positive and negative. Let positive and negative be the two charges. They are opposite charges, they always attract. And repulsive for the same or like charges. So repulsive forces act between the positive and positive, or negative and positive. The Coulomb's law is the core subject of this electromagnetic force. Charges in motion produce magnetic effects, and a magnetic pole give rise to a force on a moving charge. It is enormously strong compared to gravitational force. So comparing to the gravitational force, the electromagnetic force always becomes so strong. Electric force between two protons, for example, is 10 raised to 36 times of the gravitational force between them. So if you are having two protons, and if you are comparing its electromagnetic force and gravitational force between them, we can see is that it is about 10 raised to 36 times greater. The electromagnetic force is greater than the gravitational force, or like at a fixed distance. Electromagnetic force can either be attractive or repulsive, but in case of gravitational force, it always being attractive. Comes in two varieties. Is electromagnetic force have two charges. What are they? They are positive and negative charges. Next one is strong nuclear force. The strong nuclear force binds between protons and neutrons in a nucleus. So strong nuclear force is always happening inside a nucleus of an atom. So what is inside the nucleus of an atom? Yeah, only protons and neutrons. So strong nuclear force binds the protons and neutrons. It is the main reason by which a proton or a neutron is inside a nucleus. So it is about strong nuclear force. Without some attractive force, a nucleus will be unstable due to electrorepulsive between its protons. We know that the like charges always repel each other. So if we are taking the case of a nucleus, other than hydrogen we have helium, lithium, beryllium, etc. many elements. So if we are taking the case of a helium, it has two protons inside the nucleus. So inside the two nucleus, if we have the same protons, we know that the same charges always repels each other. They never attracted, they are always repulsive. According to the electromagnetic force, it is always repulsive to each other. So there is a force that binds that two protons inside a nucleus. Protons always stands inside a nucleus. So there will be a force which is much stronger than that repulsive, that electromagnetic force inside that nucleus. So what is that force? That is the strong nuclear force. This is the attractive force and cannot be gravitational since the force of gravity is negligible compared to the electric force. There is a force, it is never gravitational force because it is comparing to electromagnetic force. We know that the gravitational force is very low, so it is not the reason why the nucleus is being binded, but there is some force that binds the that binds the nucleus. That is what strong nuclear force. Other than the electromagnetic force, it is much greater force which binds the nucleus together. That is electromagnetic strong nuclear force. So the strong nuclear force is the strongest of all fundamental forces. So, this is very important. That is, a strong nuclear force is the strongest of all fundamental forces. We know that electromagnetic force is greater than gravitational force. But comparing to the electromagnetic force, we should have a force that is much greater than an electromagnetic force, because then only the protons inside the nucleus uh, will be bounded inside the nucleus. So that is the strong nuclear force. It is about 100 times greater than the electromagnetic force. It is always a charge independent and act equally between proton and proton. So one of the main feature of this strong nuclear force is it is always a charge independent and it always act between a proton and another proton, a neutron and another neutron, and a proton and a neutron. So what's inside a nucleus? We have protons and neutrons. So this electromagnetic force is independent and act equally between these protons and neutrons inside the nucleus. Its range is however extremely small, of about nuclear dimension 10 raised to minus 15 meter. So it's about its range is extremely small. So we know that nucleus is very small. So up to that small range only it's getting. It is bounded up to that much. So the range is very small. It is responsible. It is the only force that is responsible for the stability of the nucleus. Now we have the weak nuclear force. Weak nuclear force appears only in certain nuclear processes such as beta decay. So, weak nuclear force happens, but it happens only at the time of a beta decay. What is beta decay? Have you ever heard of what is beta decay? It is an emission of beta decay. In the beta decay, the nuclei emits an electron and an uncharged particle called as neutrino. So in a beta decay, the nucleus always emit an electron and an uncharged particle called a neutrino. The weak nuclear force is not as weak as the new gravitational force, though we have the name weak nuclear force, but it is not as much as weak as gravitational force. The gravitational force is the very weakest force among the fundamental force. The range of the weak nuclear force is exceedingly small, of the order about 10 raised to 36 meter. So range of the weak nuclear force is of the order 10 raised to 36 meter. So we will be having a table. This table discuss about the the four fundamental forces, its range, how it operates among each other, etc. So we can discuss. First one is gravitational force. What is the strength of a gravitational force? It's about 10 raised to minus 39. Its relative strength is about 10 raised to minus 39. Its range is from infinite. So We know that stars, moon, sun, etc., everything in the universe experience this gravitational force. So the range of a gravitational force is infinite. It operates among all the objects among the universe. Next one is after gravitational force, we have the second one, and the weak nuclear force. We have the weak nuclear force. This is weak nuclear force. It's about 10 raised to minus 13. That is, relative strength is when gravitational force is having the lowest relative strength. That is 10 raised to minus 39. Now when it comes to weak nuclear force, it's about 10 raised to minus 13. It is very short subnuclear. Actually, we are saying relative strength according to the strong nuclear force, that is 1. If strong nuclear force is 1, comparing to this, the weak nuclear force is 10 raised to minus 13. Comparing to the strong nuclear force, gravitational force is 10 raised to minus 39. I hope you got it, right? So comparing to strong nuclear force, the weak nuclear force is about 10 raised to minus 13 and gravitational force is about 10 raised to minus 39. Then weak nuclear force, we are discussing weak nuclear force, right? So it is very short subnuclear size. It happens in the subnuclear in size, and it experience as we have said, its experience between the elementary particle especially happens in beta decay process. Now electromagnetic force. Comparing to strong nuclear force, if strong nuclear force is about of the strength 1, then it is about only 10 raised to minus 2. It is also a range of infinity, and it operates between the charged particle, that is positive and negative charged particles. Now the last and the strongest force among all, that is strong nuclear force. Its ranges from 1. This 1. Its relative strength may be 1, and it is very short and operates between inside a nucleus. Its range operates between inside a nucleus and operates among nucleons, heavy elementary particles, etc. It operates among nucleus, heavy elementary particles, etc. So we have the fundamental force according to their strength. If, as I said, if strong nuclear force is 1, the electromagnetic force will be about only 10 raised to minus 2 in strength, and weak nuclear force will be about 10 raised to minus 13 to minus 16, and gravitational force about 10 raised to minus 38. So strong nuclear force, let it be S, which is greater than electromagnetic force, that is E, which is also greater than weak nuclear force, that is W, which is greater than gravitational force, and this gravitational force we are experiencing now. We are experiencing the gravitational force now. It is the smallest among all other forces. So this is all about the physical world, chapter 1 plus 1 physics. Thank you.